Okay, welcome everyone. Today I'm going to discuss the circuits from 2008 to 2023. So this is the basic, subject which we can score more marks actually in prelims and in also mains. So let's go to the first question. So you can observe the year in every question here itself. So I'm not going to tell every time. So this is this particular year and all. Okay, so let's go to the first question. Okay. So they asked the value of V. So here it is the V voltage. So the current is V by 1. So V by 1 is V only. So 3 ampere is coming here and V is going here. So the current will be 3 minus V here. Right. So now I am applying KVL here. So that will be minus V plus 3 plus 1 into 3 minus V equal to 0. So 6C minus 2V equal to 0. So V equal to 3 volt. So this is the answer. Okay. Now going to second question. Okay. This is the second question. They ask the value of current I. Okay. So this is 5 volt. So here also 5 volt. So current is simple. Voltage by resistance 5 by 1. So answer is 5 amp. Okay. Next coming to third question. Okay. This is the third question. So they said that a source of 2 volt with internal resistance 1 amp, 1 ohm is connected at the positive terminal of A. That means here there is a voltage source with the internal resistance 2 volt and 1 ohm is connected. Then current through R. I mean this current they asked. Okay. So let me assume this is V2 and this is V1. Okay. So apply the nodal analysis. So V1 minus V2 by 1 plus V1 by 1 equal to 1 amp, right? So this is not 1 ohm, this is 1 amp. Okay. So 2V1 minus V2 equal to 1. Okay, let it be equation 1. Now coming to second equation here, V2. So V2 minus V1 by 1, V2 by 2 plus V2 minus 2 by 1 equal to 0. So multiply with 2 LHS and RHS. So 2V2 minus 2V1 plus V2 plus 2V2 minus 4 equal to 0. So 2V2, 2V2 and V2. It will be 5V2 minus 2V1 equal to 4. Okay. So we want to know the current through R. So current through R here. So we need V2. So 5V2 minus, you can write 2V1 equal to 1 plus V2, right? From the equation 1, 2V1 minus V2 equal to 1. So 2V1 equal to 1 plus V2. So here I substituted that. So by 5V2 minus V2 equal to 4V2 equal to 5. So V2 equal to 5 by 4. So current is V2 by 2. V2 by R, which is 2. So 5 by 8, which is equal to 0.625 ampere. Okay, so option will be option D. Okay. Now coming to fourth question. They stated that there are two branches. Okay, like this, and the current is supplied like this. Okay. So branch 1 is with resistance of 1 ohm and some j omega into L1. So branch R2 resistance of 1.5 ohm and it is L. Okay. So here L1 they had given is 30 microhenry. So what they want to is I1 by I2, which is I1 means I1 and this is I2. Okay. So this ratio is independent of frequency. Okay, independent of frequency. Okay, so let me write I1 by I2. So I1 by I2, I can write like, so V by 1 plus j omega L1 by V by 1.5 plus j omega L, right? So V is the voltage across this terminal, this whole branch. Okay, so what I can write is 1.5 plus j omega L by 1 plus j omega L1. So see what I will do, 1.5 plus j omega L by, I multiplied denominator with 1.5, okay, and numerator also with 1.5. Now 1.5 plus j omega L and 1 here 1.5 plus j omega L1 into 1.5. If this, if you observe the numerator and denominator, if both will be cancelled, what is the ratio? I1 by it equal to 1.5. So this term is independent of omega, right? So what I want to do is 1.5 plus j omega L equated to 1.5 plus j omega L1. So L, okay. I did a mistake here. Here 1.5 I had to multiply here also, right? So into 1.5. Okay. So omega, so L equal to 1.5 L1. So L1 is already given 30. So answer will be 45 microhenry. Okay. Oh, so okay. So coming to fifth question, this is RLC circuit with a DC supply. So let me assume current I of S in Laplace domain equal to V by S. As this is DC supply, so Laplace transform is V by S plus R plus SL plus 1 by SC, right? So if I do if I solve this, so V by RCS plus S square LC plus 1, right? Into C, it will go up C, right? So V by L into S square plus R by L S plus 1 by LC. Now substitute the values. So V is given 50, L is given 0.5. So X square plus R by L. R by L is 5 by 0.5. So 5 by 0.5 is so 10s plus 1 by LC. So 1 by LC value is 1 by 0.5 into 0.08. So it will be 123 by 40. So it will be 25, right? So 100 by S square plus 10s plus 25. So 100 by S plus 5 whole square, right? So I can write 100 into t e power minus 5t. So this is the time domain representation of the above Laplace equation. Okay, so answer will be T. Okay, next coming to next question. So this is missions question, and this is also mission. This is measurements. Okay, now come to 10th question. So 200-watt lamps are connected in series. This is one lamp, and this is one lamp. So these two are connected in series and across a 200-volt supply. Okay, so the total power consumed by each lamp. Okay, so first calculate the resistance of each lamp. R equal to, so V square by P, right? So V is given as 200 square by 100 watt. So this V is the rating of the bulb and this P is the rating of the bulb only, I mean lamp only. So answer will be 400 ohm. So the resistance of each lamp is 400. So 400 is across a 200 volt. This is 400 and this is 400. So the total current is voltage by 800, right? So the current is 1 by 4. So power consumed by each lamp equal to I square into 400, right? So 1 by 4 square, 1 by 16 into 400. So it will be, I think, 2 and 5, right? 25 watt. So answer will be 25 watt. So coming to next question. Okay. Question number 12. So the active and reactive power of inductive circuit are 60 watt. Okay, and 80. So P is given as 60 watt and Q is given as 80. Yeah. So the power factor they ask. From this you can calculate S equal to root over P square plus Q square. So S is the apparent power. So 60 square plus 80 square. So it will be 100 volt ampere, right? So power factor, if you want to calculate power factor, you just do the P by S. We know na P equal to S cos phi. So cos phi is the power factor. So cos phi equal to P by S. So power is 60 by 100. So 0.6 power factor. Okay. Now this is also power system question. This is also power system. And coming to 15th question. So a terminal where three or more branches. So this is one branch, and this is one branch, this is one branch, and this is one branch. So all these meet at a point, which is called as node. Okay, this point is called as node. So answer will be node. Okay. So coming to 16th question. So find the current through 5 ohm resistor. So 10 ampere is given, 2 and 5. So this is simple current division. So 10 into 2 by 2 plus 5. So 20 by 7. So approximately 3. So approx answer 3 is 2.85. Okay. Okay. So coming to 17th question. Determine the voltage at point C shown in the figure with respect to ground. So let it be ground. So this is 0 volt, right? So this is 12 volt. So you want the voltage at point C, right? So this is simple voltage division. 12 into 50 by 50 plus 100. So it will be 40 volt. Okay. Okay. So find R3 of the circuit shown in the figure. Okay. This is the circuit given. So we have to find the R3 resistance. Okay. So in order to get the R3 resistance, so let me write here. We need voltage across R3 and current through the R3, right? So if you see 50 milliamperes is going like this and 10 milliamperes going like this. So the remaining current 50 minus 40. So 40 milliamperes will go like this, right? Right. So the current through R3 will be 40 milliamperes. Now voltage across R3 will be voltage across R2. So voltage across R2 equal to current through R2 is 10 milliamperes and resistance of R2 is 10 kilo ohm, right? So it will be uh, so 100, so 1000 volt. So R3 equal to 1000 divided by 40 milliampere. So 4 2s are 8. So 4 2s are 25. So 25 kilo ohms will be answer. 25 kilo ohms will be answer. Okay. Okay. So coming to 19th question, find the node voltage VA. So they asked the voltage here. Okay, this is simple nodal analysis. So VA minus 12 by 1 plus VA by 1 plus VA minus 6 by 1. So 1, 2, 3, 3 VA minus 18 equal to 0. So VA equal to 6 volt. Okay. So coming to 20th question, a node in a circuit is defined as. We already discussed node is a point where there are many branches met. Okay. So if you see, it is like D option, junction of two or more elements. So it will be option D. Okay. Coming to 21 question, the voltage across 1 kilo ohm resistor of the network shown in the figure. Okay. They want the voltage across this V. So this is just a simple nodal analysis question. V minus 10 by 2. So V by 1. So V plus 2 by 2 equal to 0, right? So if you solve this, v minus 10 plus 2v plus v plus 2 equal to 0. So 3v, 4v equal to 8. So v equal to 2 volt. So option will be answer C. So coming to the next question. So they want the current I here. Okay. So if you see this 2 and 2 is coming, it will go here 4 amp. So 4 is coming, 1 is going up. So it will be 3 amp. So 3 is coming, 1 is going up. So 3 minus 1.3, that equal to 1.7 ampere. So option will be D. So which of the following determines the total power in a series circuit? So generally power is what? So there is a series circuit here, some impedance is there and voltage is there V and current is there. Okay. So power is voltage into current, right? So answer will be source voltage times of the current. Source voltage times of the current means V into I. Okay. So answer will be A. So Kirchhoff law is applicable only to. Okay. So only to Kirchhoff law. So okay, this is KCL, right? So KCL is what? This is right. It is a junction of some points. So some branches. It is a junction of some branches, right? So KCL is valid at a junction in a network. So option will be C. Okay. So coming to 25th question. There are 10 nodes, okay, and 17 branches. Okay. So the node pair, they want pair voltages. Okay. So pair they want, so we need to take two. I mean, suppose there are, let me assume there are three nodes. Okay. One, two, three. So we need pair means one, two, one pair, one, three, one pair, like this, right? So that 10 nodes. So we want pair means 10 C2 combinations will be there. So 10 into 9 by 1 into 2. So answer will be 45. Okay. Now, find the currents I1, I2, I3, and I4 in the shown figure. Okay. In this question, there is a mistake. This resistance is not 1 ohm. So this is 4 ohm, and this is 5 ohm, and this is 1 ohm. So actually, there is a mistake. So assume the voltage will be V. So V by 4 plus V by 5 plus V by 1 equal to heat. If you multiply with 20 on both sides, then 5V plus 4V plus 20V equal to 160. So V equal to 160 by 29. So I1 equal to 160 by 29 into 1 by. So general I equal to V by R, right? So this is the voltage divided by resistance 4. So 40 by 29. So it will be 1 point, I think 38 ampere. Okay. So I2 equal to say 160 by 29 into 1 by 5. So it will be less than 1.38. So you can see option A and C are more suitable. Okay. And I3 is 160 by 29 into 1 by 1. So it will be uh, how much? Let's calculate 160 by 29 first. So 29 by 160 is around, so let it be 29 5 and 5 are 45, 145. So it will be greater than 5, right? So 29 6, 9 6 are 54, 60 is 12, 17, 174. So it will be greater than 5 and it will be less than 6. So most suitable answer is this one. So option A. So actually in plain, no need to solve the accurate points. Just do the approximate analysis. Okay. Then you can save your time. Now coming to 27 question. So let's make the circuit more clearly. Okay. So this point, actually this is not a junction, it is like this. Okay. These two are not connected. Okay. So this point and this point, both are same. So I can connect this resistance as like this, right? And the this resistance plus this point and this point, this, right? So I can connect inductance like this, right? Now this and this, I write resistance as like this. Okay. So if you observe how many loops, 1, 2, 3, 4, and 5. So the number of mesh currents will be 5. Okay. Hmm. Now which of the following statements about the circuit is true? Now if you see these three are in series, okay, these two are in parallel. So the voltage circuit are in series, this is wrong. The resistance R1 and R2 are connected in parallel, this is wrong. Because it is in series, right? So the voltage V1 and V2 are connected in parallel, right? The resistance R1, R2, R3 are connected in parallel, this is wrong. So option C is the answer. So Kirchhoff law states that in a closed circuit, okay. So if you see a closed circuit, okay, in the closed circuit, you know that voltage is equal to zero. Like this is a circuit of 5 volt and R1 and R2. What we will do? Minus 5 plus voltage across VR1 plus voltage across VR2 equal to 0. Means across the, across the loop, the sum of the voltage will be 0, right? So, so the total current algebraic sum is 0. This is wrong. Okay. And the algebraic sum of the potential difference is right. This is 0, right? Algebraic sum of current is 0. This is wrong. This is wrong. So option will be B. Okay. See, they have given this 35 volt and 600 ohms and resistance R. So R and this is 35 volt. Now a two 1 point a voltmeter is connected which has internal resistance of 1.2 kilo ohm. So 1.2 kilo ohm resistance it is there. This is 600 volt. So the voltmeter reads the voltage across this is 5 volt. Okay. So then find the value of R. Okay. So now solve this circuit. 35 volt. So these two are in parallel. So 600 into 1200 by 1200 plus 600. So it will become 400 ohms. So 400 ohms and the voltage is 5. So by voltage division, voltage across 400 equal to 35 into 400 by 400 plus R. So this we know as 5 volt. So by solving 5 into 400 plus R equal to 35 into 400. So 5 sevens are, so R equal to 2800 minus 400. That equal to 2400. So that is 2.4 kilo ohm. So option will be B. Okay. Okay. So KVL is applied to which circuit? So generally KVL and KCL are valid for any type of network. I mean linear, active, passive, time variant, time invariant. So generally it is KCL and KVL are not valid for distributed networks. Okay. For distributed networks it will be not valid. So here it is not given any distributed network. So it will be valid for linear, non-linear, active, passive, time variant and time invariant. Okay. Okay. So the current through ZL in the circuit for the below circuit. So they asked the current through this. Okay. So I think the question is wrong. So I think for the current through ZL when maximum power is transferred, I think. Okay. So when the current through ZL when maximum power is transferred, then ZL equal to this let it be ZS, then magnitude of ZS. Right. So I think this is the question. So I think this is incomplete question. Okay, this is incomplete question because here in question it is not mentioned maximum power. Okay, if in question suppose it is mentioned that I mean for maximum power, then how we will do? So ZL equal to ZS conjugate. So ZL equal to 10 minus J20. So current equal to 50 at an angle 0 by 10 plus J20 plus 10 minus J20. These two will be cancelled. So answer will be 50 by 2, which is equal to 2.5. So answer will be this. But in question it is not mentioned for the maximum power transfer. Okay. Okay. So